Hey everyone, Kunal here again. And today we will be looking at another problem. Rather, we'll be solving a problem using Raptor. And for today, the problem that I've chosen is to find the nth term in a Fibonacci series. And we'll essentially be doing that using recursion. I will demonstrate how you can go about finding the nth term, nth value in a Fibonacci series. And we'll be using a concept called functions. I have introduced functions previously in one of my videos, but I will do some explanation here, and uh, we'll use another concept called recursion, and I'll explain how these things work. Now, those of you who know DSA, I know this is not a very good way of solving this kind of a problem, because uh, it won't be an optimum solution as far as time complexity is concerned. But we will be covering this problem in greater depth once we start our regular DSA and algorithm uh, series. Till then, I am just trying to bring out some basic concepts, concepts like looping or iteration, concepts like branching or conditionality, concepts like recursion, concepts like functions. So we'll try to understand this, and once we deep dive into DSAs and algorithms and a little bit of maths that would be required to solve these kind of problems, I will be giving a more elaborate you know explanation about these concepts. All right. However, let's just focus on finding the nth term for now using Raptor of a given Fibonacci series. Now, for those of you who don't know what a Fibonacci series is, it's the Fibonacci series is of the uh, nature of the following. It starts, let's say, from 0, 1, 1, 2, 3, 5, 8, 13, 21, so on. If you can see this series, the term 21 is nothing but the sum of its previous two values. So it's nothing but 13 plus 8. Similarly, if you see 13, it's nothing but 8 plus 5. If you see 8, it's nothing but 3 plus 5. Sorry, 5 plus 3. So the current term in a Fibonacci series is nothing but the sum of the preceding two values. So the most current term in a Fibonacci series is the sum of its previous two terms. This is what a Fibonacci series is. And our task is to find the nth term. So the user will usually define what that n will be. We have to find the nth term in this series. So let's say the user wants to find the fifth term. So fifth term will be 1, 2, 3, 4, 5. It will be 3 in this case. All right. So for that, let's just ask the user. So let's begin. I will use a standard input box. I will ask the user to enter the number for which the value within the Fibonacci series is desired. and I will store it in a variable called n. So enter the number for which the value within the Fibonacci series is desired. What is that n? So that is usually a user input. We'll get it as a user input. Now at this point, like I said, want to use recursion to solve this. I'll be using recursion to solve this. There are different ways to solve it. You don't necessarily have to use recursion, and we will see each how you can solve this kind of a problem using different approaches and what would be the most optimal approach. But like I said, we'll be doing that in a separate video when we deep dive into DSS. For now, I will would want to create a function. Let's call this function Fibo. Okay. So I am creating a function, and okay, I'll demonstrate this again for those of you who don't know how to create a function using Raptor. Just have to right click on the main tab here. There's a menu item called add procedure. Click on that and it gives you a input box like this where you define what your procedure name is. So you begin with that, and my procedure name is Fibonacci. Let's say FIBO. Fibonacci. Now, of course, my input parameter. I want to find the input. What would be the input here in this function? Now, of course, the n which I get from the user has to be supplied to this function as an input parameter. Unless I do that, I this thing will uh, run indefinitely. So I don't want to do that. So let's give an input parameter as a num, which is essentially going to be n once I call this function from the main tab. All right. So I have a num which I will provide as an input to this function, or as a parameter to this function. All right. I will also want an output because I want this function to return, to give me back the value. Sorry, the value or the term. So let's call it the term. So, or let's just keep it value. Let's call it value. And I would rather call this the number. So which term, which number, fifth, sixth, seventh in the Fibonacci series do you want? And the output has to be value. And if you can see, I have unchecked the input box and I have checked the output, you know, box here. So this value is not a input; it is going to be a output. All right, and my function gets created. So it's taking one parameter, input number, and it's going to return me some value, and that value should be the exact value of the Fibonacci series corresponding to this term. All right. Now, if you see, the Fibonacci series starts from 1, and because intuitively you will realize that each term in this Fibonacci series is a sum of its preceding two numbers. So if you see 21, it's nothing but 13 plus 8. If you see 13, it's nothing but 8 plus 5. 5 is nothing but 3 plus 2. So I will need two numbers to begin with. Because if you can see this 0, there is nothing preceding 0. And if you can see this 1, there is only one term, that is 0, which precedes this one. So the first two terms would be base cases, and when we talk about recursion, there is something called base cases, which we will again, like I said, deep dive and try to understand. So just for those of you who may want to subscribe to my channel, please, I will be putting out an entire series on DSS and algorithms, along with some essential mathematics that you will be required to understand. Maths like um, maybe a little bit of calculus, discrete algebra, uh, and some statistics and probability. It won't be a complete mathematics program, but I will give you some idea about what maths we use. Then we create these kind of algorithms. All right. So we will need two base cases, and the best way to create a base case is to use a selection. So we will use a selection box here, and I will create my first base case where my term number is equal to 1, which means my first term, if my term number is 1, so my first term, if you can see, is 0, I will only say, because I am storing all my output in value, I will say set value to 1. Oh, sorry, 0. First term is 0. So value will be 0 here. So first term, if yes, if it is 1, the value will be 0. And if not, then I will again check if the term number is 2 or not, is equal to 2. So the second term, which is also a base case, if it is yes, I will simply say the value is 1. All right, base case is done. These two base cases have been defined, 0 and 1. And now I can use my recursion. And the way to use this recursion is to call this function again. So I will call this function again, and I will call it recursively till I reach the base case. Now, this is how it works. What I will be doing essentially is I will use this call symbol here to call my Fibonacci function here again, which I will call with some changes to the input and output parameters. And this is the important part here. My function name is Fibonacci, so I will write Fibonacci. And the input here will be term number -1. This will be the input, that is the term which precedes the current term. And let us say I want to store this result, whatever the result is, in a variable. So I had said value as the output variable. I will use v1 as the output variable. This function is complete. All right. But this is just one part. I want two terms. So if you can see, for 21, I have found out the 13, or I have done something to find the preceding term. I want to go back one more step. So I need 8 also here. And to do that, I will again copy this. And here I will say the term number -2, and I will store it in, let us say, V2. Now I have both the preceding terms. Now the way recursion works is, this will keep on I this will just keep on, computing or going back. So for, let's say, to find the uh, term at 21, I need 13 and I need 8. So this function here should give me 13. This function here should give me 8. But because I am using recursion for this 13, the function will call itself again. So 13 is not known for the function right now. It will go back one step and compute 13. For 13, I will need 5 and 8. So again, it will compute what is 5 and 8. For 8, it will go back and compute what 5 and 3 is, and so on. So this is how recursion, calls itself. And I will, once we start doing DSS, we will be seeing this in more depth. Like I said, will use some visualization tools. This is, if you know DSS, or some of you knows DSS, it's basically a binary tree. So we won't be discussing what binary trees are and how it works right now. We're just trying to implement this Fibonacci problem using recursion and Raptor. All right. So now I have the preceding term and the term before that, these two terms, and the output is V1 and V2, and the final step I have to do here is to assign to my value V1 plus V2. My Fibonacci function is created. And let's go and check it. Let me call the Fibonacci function here. Let me say my input term is 5, and let's say I want the output in a variable called V, and let's see if we, and the output is fifth term in the Fibonacci series is plus. See if this works. So, oh, okay. So I have taken a direct value here. So is 3. So anyways, we didn't use the input box here. So let me just say n here and make some modification here. So instead of fifth, I will say n. And now it's much more elegant. So let's say I want the fifth term. The fifth term in the Fibonacci series is 3. So let's check. One, two, three, four, five. It is 3. Let's see. Well, let's check with something else. So let me close this. Let's check with, let's say, 8. The 8 term is 13. It indeed is 13. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Eighth term is 13. So this is how you will be using the recursion to find the nth term in a given Fibonacci series. It's quite a simple solution. Like I said, it's not a very optimal solution. We will be seeing this in more depth once we start visiting all the data structures that we have at our disposal. But I hope you liked that video. I will continue making these videos for you to at least start understanding how to code uh, and how coding works. So these videos are for the beginners. If you want to know more, or please do write to me, write in the comments. I would be making specifically those videos. Uh, so do write to me. Do let me know what exactly would you like to know, and I will do my best to create those kind of videos. All right. So thank you for watching. See you next time. Bye.